Our second speaker for stormwater management treatment media this afternoon is Dean Rissetto, talking about ensuring quality supply of media for bioretention treatment devices.
Hi, I'm Dean Rissetto, Director of Essential Landscape Supplies, Silverdale and Waiheke, Rissetto Stone and Scapespec. We have a focus on engineered soils and have been involved in the development and supply of media for bioretention devices for several years now. Over this time, bioretention devices such as rain gardens and tree pits have become increasingly recognised as important in the urban environment, not only for the filtering of contaminants and reducing stormwater discharge peaks and volumes. There's also a large body of research that talks about the social and cultural benefits of bioretention devices and green spaces. When they work with healthy plants and reasonable aesthetics, they're hugely beneficial for our mental health, our well-being, and also for maintaining our waterways for future generations. Bioretention media underpins device performance. It's a highly technical product. But rather than going into the technical product specifics or the substantial research as to why, how, and where we should employ them, today I'm going to take a more practical approach, focusing on the dynamics of specification, production, and installation from a supplier's perspective. So as a producer of bioretention media, we're quite commonly a pivot point. We're exposed to many projects with different specifiers, contractors, and installation requirements. So looking across these projects and as an industry, how are we doing? And are we getting the results we want? The answer appears to be yes, but inconsistently at best, both in Auckland and nationwide. So what's going on? Failure in these projects can be a big deal. Media remediation can be very expensive, and it can often be difficult to understand exactly where the liability falls. Was it the product or the way that it had been installed? Or was it the right product or specification in the first place? From our perspective, there appears to be a combination of factors involved. One key factor is product specification. As an industry, we face difficulties in specification, particularly site-specific specification and outcome-driven specification. What we have found is a blend of council documentation and international standards being specified on tender documents. Quite often these are conflicting, and the products meet either the council or international specs, but not both. Specification is often focused from one perspective, such as optimal design, and not taking into consideration the construction or the ongoing maintenance and planting requirements. There's also some questions around the methodology that is being used when testing the infiltration rates and how closely aligned the lab testing is with actual in situ results. Auckland Council currently have some useful specification guidelines for bioretention media. It's fairly comprehensive in terms of its technical aspects, broadly covering all devices. However, sometimes they're not specific enough to the site, particularly around the installation process. There's discussion around allowances for different devices and sizes, but not in the product specification and installation method, particularly around the compaction of the media. In fact, in some projects that we've been involved in, if you actually followed the council guidelines, it could have resulted in a failure. So we're having to ad hoc as we go. So how do we know what to mix? What is the optimal blend? And how do we account for site-specific blends? International standards are commonly referred to with specification documents supplying blend ratios of each of the products. But one of the key issues with international standards is that they don't take into consideration the raw products that we have here in New Zealand, or even regionally within New Zealand. For example, they sometimes specify a percentage of a particular component, such as soil. The problem with this is raw soils can have the same particle size distribution as each other, but the hydraulic conductivity of a soil from within Auckland, say North Shore to Pukekohe, let alone Auckland versus Waikato, or even Melbourne, could be vastly different. Changing the soil can fundamentally change the infiltration rate, even when soils are only 20 to 30% of the volume of a mix. So change of a soil blend can change the media effectiveness quite dramatically. The same applies for sands, maybe even more, as they often make up a significant percentage of the blends and have different properties based on how the sand particles were geologically formed. Sand shape and PSD can affect the compaction and the infiltration rate. Some sands are also chemically active and help mitigate contaminants, while others don't. The guides are often very loose, if available at all, and there are many out there just pulling it together and saying, hey, this looks about right. So while there's been a lot of work done and success in those key CBD projects, outside of the cities, there's still some pretty rogue practices. There's largely a price-driven approach to media supply. There's also a push from suppliers who are also raw product producers to use a higher percentage of their raw products in the blend. Quite often, this can be to the detriment of the end product. For example, we were asked to develop a tree pit mix that had just enough organic matter to sustain the plant growth. The contractor had an issue with a previous supply of a media that was breaking down due to high percentage of organic matter. Settling due to vibration and water movement could also have contributed. The result was media in the tree pits were up to 300 mil lower when first installed. This was becoming an issue where the tree roots were being exposed and there was little or no access to top up the tree pits, as they're commonly enclosed or paved over. So it's important to note that we do understand and find suppliers and industry experts with the technical knowledge to contribute and advise in installing and getting the right blend. It's also very important that once that blend is determined, that there's consistency in the raw materials. Ideally, we need to single source supply to ensure the consistency in our production and outcomes. If a blend has been tested and has the right attributes with 10% of a certain soil, you can't just replace it with 10% of a soil from either a different source or even a local product and expect the same results. So when you're relying on a third party to supply a raw product, such as a sand, you need to ensure that the particle size distribution on those sands is consistent. Most sand quarries will have a number 1, a number 3, and or a 2000 sand. And while labelled the same and looking very similar, they can be different in both particle size and shape, again resulting in huge changes in the infiltration rate. If they change where the sand has been mined in the quarry or the machinery that's been used to screen the sand, there can be a variance in the PSD. And a very small change in PSD can have a very big impact on the infiltration rate, affecting essentially the effectiveness of the soil. This does come from experience, and we now have systems in place to detect those changes. It's also important to ensure that there's enough raw material to supply the life cycle of the project that you're currently on, as you don't want to be chopping and changing. A second part of the consistency is in the QA and QC process of blending. Even if we have the right raw materials and specs, if the product is not consistently blended, we'll also potentially expose ourselves to product failure. Taking the time to follow the process and work in a clean site are quite key to keeping the product consistent. There has been instances where we've witnessed product being blended on site with diggers and not on concrete, which significantly increases the opportunity for error and risk of failure. Many have no or very limited testing regimes. Often they do enough to get past the specifier, but there's little ongoing checking across the life cycle of the project. There are a lot of moving parts to consider, and this is where we see another clear breakdown. There are many parties involved in these projects. Those involved have various experience, knowledge, and motivators. There's often a disconnect between specification and translation to what arrives on site. Architects or specifiers don't always have an ongoing communication channel with the suppliers. Specifications are typically translated through the contractors. This can turn into Chinese whispers, and there tends to be a reluctance to share design documentation. Landscape architects understand the outcome they want. However, they often copy and paste documentation from previous jobs. Suppliers sometimes see those specifications, but are more often than not just told the quantities required without a clear brief or of the exact specifications for the site until it's far too late. For example, where there's a specific requirement for planting, weight loading, or accessibility. This can result in a supplier being faced with unrealistic expectations of products, timeframes, and pricing. Contractors tend to be very price-driven. Understandably, it's a tough market. They're also time-driven. They prefer not to wait for a product to be developed or be subject to testing. Some don't always share the same understanding of how the product works and the impact changes or choices they make have on desired outcomes. For example, in a job we're involved in outside of the CBD, we had a contractor who didn't understand what the product was really meant to do. There were two areas with two different suppliers of a rain garden mix. Talking to him on site after heavy rains, he'd considered that the product which was dry had worked and the other which had slight pooling on the surface had failed. It was in fact the exact opposite. The one that was dry was draining far too quickly, meaning contaminants wouldn't have been filtered and there was not enough moisture being retained for plant growth, whilst the other product was working perfectly, slowly filtering and retaining moisture for planting without flooding. This lack of understanding, it's not uncommon. In fact, there appears to be some with the attitude out there that the bioretention meter don't actually work. It's a nice to have, save the planet, time and money trap. It becomes a checkbox exercise, corners are cut, and price-driven product sourcing results in substandard outcomes, which reduces the effectiveness and increases liability and risk through the supply chain. Others, however, are acutely aware of the benefits and try to get it right on site, yet they still struggle with the complexity in getting bioretention devices to work. There are some really good experts in the field, and while we've had a more collaborative approach with some, it still takes time for that to transfer into product hitting the ground. We're not effectively sharing and working on it together. We've got competing priorities, and even though we're all pushing for the best outcomes. How do we move forward? This is where we've been focusing a lot of our efforts to help our industry lift those standards. What do we need to do? Firstly, more testing. We can't always control nature, but we need to figure out the variables we're working with and adapt. So one of the key elements of future success is looking at the frequency, the timing, and the way that we're testing. Industry testing regimes need to be more robust to optimize outcomes and also provide confidence and assurances to the project stakeholders. Testing at the point of installation would be beneficial to increase our understanding and determining optimal compaction for different media and devices. More often than not, once the project has been signed off, there's little looking back to see how that media is performing. And we're losing that opportunity to learn and develop by not testing how those products installed are working. There needs to be more testing out of the lab and in the field, gaining a greater understanding of how on-site testing aligns with pre-install lab testing, mapping changes to the hydraulic conductivity of the media over the lifetime of the bioretention device. We often hear objections to testing around cost or even fear of liability. However, testing is likely to reduce those long-term costs and the liability, helping us to grow our understanding of creating longevity in the products being installed. In addition to testing, we need to know what we're testing for in regards to those site-specific needs. If we're to look internationally, not at what councils are specifying, but what the suppliers of the bioretention media are doing. Suppliers are providing a variety of media blends to suit the different types of bioretention devices, rather than trying to force them into one box. We need experts developing bespoke mixes who understand product requirements and specific raw material properties, as well as the development of a variety of approved media. For example, 3 different rain garden alternatives are suited to different bioretention devices. Creation of alternative standards would help speed up the design and specification process, reducing the need for frequent bespoke product development and offering benefits in terms of time and cost. This would also help with install guidelines for the different devices and medias. Using this strategy, we would not need to reinvent the wheel every time. We'd simply select the correct media for the device or the desired outcome. The key to this is increased collaboration. We need to share more and leverage the expertise of all shareholders or stakeholders. Every time we've worked collaboratively in the early stages of a project with industry leaders, council experts, landscape architects, engineers, and all the contractors, we've had really good results. For example, we were approached by an industry expert to design and develop a product with enough structure for tree stability and growth to use in the Metrogreen strata cell system. Working with them, we're able to come up with a solution that has now demonstrated success and has become the preferred material for the strata cell system. If a supplier is asked in the weeks before installation to produce unrealistic media, for example, around weight loading, there's little space for pushback or alteration as the design process is over. This creates difficulties across the board, impacting cost, timeframes, and effectiveness. Quite often, as suppliers, we are kept at arm's length by the contractors. If we're able to have more open and frank discussion around the different variables, we could support better outcomes. We need to work together up front rather than looking at who to blame when it doesn't work out as planned. Increasing testing, specifying site-specific media, and collaboration may seem to point to a huge increase in complexity, time, and resources. So how do we work with this and tie it all together in a feasible way? By leveraging technology. Using technology to increase connectivity and streamline processes and systems. This is an area where we've been placing more focus in to great success. In creating engineered soils such as our RG240 rain garden mix, we had to consider the dynamics involved, such as the processes around blending, testing, ordering, and also catering for multiple blends at one time. This led us to look at how we could use technology to streamline the process, making it easier to offer core product range for various devices, as well as bespoke site-specific blends, building in QA and QC processes for consistency. It's about having a system that's not looking to find fault, but catching issues at the top of the hill rather than down at the bottom where the remediation is expensive. The solution for production was the development of an application, MixApp. This allows us to easily blend quantities and percentages along with the volumes. This information is sent directly to the loader operator, enabling them to efficiently and consistently work on multiple blends, reducing time and resource requirements, meaning we can do it cost effectively. Built into the system is a prompt for bagging samples at set quantities to send to the labs to be tested or referred to at a later date. We recently worked on a project where 3 new engineered soil blends were required. The site was a courtyard on the 5th level of a building, impacting weight loadings. The Mix app enabled us to plug these blends into the back end. The loader operator then used the app to easily create the blend. It also gave them a data log to refer back to and prompts for test sampling. The product is now stored in the system, tabulated with the site, and the product specifics, making it easier to replicate for future sites, and also refer back to and test over the product lifecycle. The Mix app is part of a bigger ScapeSpec system, which is currently under development. In addition to the production platform, we're building an online portal system to increase connectivity between the different stakeholders. There will be frequently updated tender documents, inserts for specifiers, and clear installation guides for installers. It will enable a seamless link and expectation through specifier, contractor, and supplier. We are seeking to continually collaborate and build our knowledge and product base, leveraging testing, streamlining systems, and increasing ease of working together. Thanks for listening, and I'd be very happy to take any questions now.